Good evening, everyone. This is Misbah. I'm from Azure School of Data Science. Today, we are here for a webinar on how to launch your career in Azure DevOps Cloud. And today, we have with us Mr. Sunil Gupta, who's a senior DevOps engineer, and he has a hands-on experience in Azure DevOps. He has worked for global MNCs. He has over 8 years of experience, and he is technologically very, very sound. So he has he has a very strong technical knowledge when it comes to Microsoft Cloud Services, um, PowerShell DS, PowerShell DSC, ARM templates, and etc. Sunil sir, you're most welcome.
Thank you so much, Ms. Ba. So, let me introduce myself.
That would be great, sir. That would be great if you can introduce yourself.
Yeah, sure. So, my name is Sunil Gupta. I'm having 8 years of experience in IT industry. I have worked for multiple companies in my past. Okay. And so far, I have worked on multiple technologies that includes Microsoft Cloud, Microsoft DevOps product, that is Azure DevOps, then Microsoft another product ARM template, then PowerShell DSC, and then again I have worked on other technologies, like Ansible, Terraform, AKS, then Linux, Windows. So all these experiences I have it. Okay, so today I'll be talking how to make career in Azure and Azure DevOps, and how to be a good engineer in terms of Azure and Azure DevOps. Okay, so before we move ahead, let's see what is. Before we move ahead and learn about Azure, so let's understand what is cloud computing. Okay, so cloud is a network. Cloud refers to a network or internet. Okay, it's basically a technology that uses remote servers to store the information. Data can be anything. It can be images, files, document, audio, video, anything. Data can be anything, and we can manage the data on the cloud. One second. Yeah, we can manage data on the cloud, okay, rather than local drives. Normally what we do, we store our data on the local drives. So for example, if somebody wants to store any data, what they do, they store the data in their desktop or in the local drives, which is hard disk. So here, using cloud technology, what we can do, we can store our data in the remote servers. Even we don't know where is those servers located. So that's what we can do. And other than storing, accessing, manage the data on the cloud, what all we can do, we can develop a new application. Like somebody wants to create a we can say a new product. For example, there are several products there, correct, in market, Flipkart, Amazon. Somebody wants to create new e-commerce application. What they can do, they can use cloud computing technologies, and they can create their service, their product. Same goes with the service APIs. Somebody wants to create APIs, what they can do, they can create the APIs. Somebody wants to store any data, and anything related to data they want to do, they can do it. Okay, they want to write some blobs, and they want to upload those blobs in the cloud. That can be also achievable. Okay, with that, and we can create our own product. Okay, and if, for example, if we have multiple data, we have so much of data, and we want to do analysis of those data, that can also be performed on the cloud. Okay, and again, streaming of videos and audios, you can see these examples, correct? Again, we are doing this using cloud technology. So there are multiple things we can do using cloud technologies. So why cloud computing? Normally what used to happen earlier, okay, before cloud computing, every company used to create their own infra. Okay, so they, for creating infra, they used to hire a people, okay, like network engineer, system engineer, Linux engineer, Windows engineer, several types of engineers they need to hire. Again, they need to hire a place, they need to put a place, correct, to so that they can create entire data centers. And to create a data centers, again, we would need server, database server, mail server, networking, firewall, router, modem, switches, lots of things we would need, correct? And this requires lots of cost. Okay, this requires money, power, resource power, and lots of time also, correct? So that was happening earlier. By coming by once, once cloud computing came in picture, what is happening? All these things we don't need to manage. Okay, what we will do, we will just use the cloud computing technologies, and we use whatever services we want to use, we'll use that. For example, we don't need to create database server. All we want, we can use that database server. We don't need to configure mail servers, networking, anything. All we can use those services, because there are lots of cloud providers, they have already created these services. Or what we will do, we will just use those services. Okay, and we can save lots of money. So let's see one picture and try to understand what was the earlier and what is happening nowadays. So if you see the before cloud computing, this was the structure of a data centers. You need to manage everything, like data center, servers, routing, switches, everything you need to match. You can see with the wires, correct? I have seen the live data centers. It's the same, whatever you guys see it in the picture, it's the same thing you will see it in the data centers whenever you get chance to visit. And what is happening, once cloud computing is introduced, what we can do, we can use those services directly. So for example, somebody wants to use SQL server, what they can do, they can create their login in the cloud providers, and they can use SQL servers. Okay, things has changed a lot after introducing cloud computing. Okay, so you guys can see the difference, correct? Okay, so let's move ahead and let's see what is the features of a cloud computing. So the one of the feature is agility. It's very fast. So if you want to access any mail server, any database server, all you need to spin up and use it. Okay, it's very fast. Earlier it was very difficult. You need to ask data system engineers, then he will purchase the license. I'm giving example of database. He will purchase the license. For example, let's take example of a SQL Server 2018. He has to purchase the license, so it will take lots of times. And what we can do now, we can directly go and purchase it. Okay, and second features is high availability and reliability. It's very Microsoft, I'll take example of a Microsoft. They provide 99.9999% of SLA, so there is no downtime. It's very reliable, and it is available 24/7. Okay, and high availability. So for example, you have one web app, you have one virtual machine, and your business works from 9 to 6. Okay, so what you can do at that particular time, you can scale the applications. Okay, you don't need to pay the money for the hours, which is when application is not being used. Okay, we can get this benefit. Then again, multi-sharing, we can share our resources to others also. It's not just limited to you only, it can be shared anywhere. And fifth, device and location independence. It is location independence. We can say that you don't know where is your data center, where is your machine located, correct? You can be accessed from anywhere. For example, if you created one virtual machine, okay, and you want to use that, so you don't need to worry where is the machine, correct? You can directly use it. And maintenance, you don't need to maintain anything. Maintenance will be done by the cloud provider. All you have to use it, and it's very low cost, and it's very low cost compared to before cloud computing. And it's like pay how much the more. It's like if you are using 10 minutes, then you will have to pay for the 10 minutes only. It's not that you have to pay for the entire month. And types of a cloud. So there are three types of a clouds available: private clouds, public clouds, and hybrid clouds. So private clouds is like we create for our purpose only. We cannot we don't want to share. For example, there is a company, one, he will create one data center just for their purpose only. Nobody else can use it. Okay, this is a private cloud. And the public cloud is available for publicly. It can be accessed by anywhere, and the vendors for the public clouds are AWS, Google Cloud, IBM, Microsoft, And hybrid cloud is again combination of a private and public cloud. Okay, it's both combination of a private cloud and the public cloud. And let's see popular public cloud providers, because and there are 5 major public cloud providers: Alibaba, AWS, Google Cloud, IBM, and Microsoft Azure. So Alibaba is founded in 2009. It's all called Aliyun. It's again cloud computing company which provides all computing services, network services, storage services. Again, then AWS is again another cloud provider. It's founded in 2006. Again, it provides all the cloud computing services. It can be data, it can be storage, it can be computing. All these services will be provided by the Amazon web services. Cloud, Google Cloud, all we all know about Google Cloud, correct? It is launched in 2008. Again, it provides all the cloud services that includes data storage. And we know the end the Google products, correct? Google search, Gmail, Google Drive, and YouTube. And IBM is again it's launched in 2011. It's a cloud computing product which provides all these services. And Microsoft Azure, it's launched in 2010. It is referred as the Azure, and it's a cloud computing technology that we can use it for storing the data, computing purpose, analytic purpose. There are many things we can do using Azure. So let's understand the cloud models. So you are seeing 4 different diagrams over here. So first one is on-premises, the second one is infrastructure as a service, platform as a service, and software as a service. So let's talk about the on-premises. In the on-premises, correct, if you see, we have to manage everything. So to create on-premises model, what we have to do, we have to purchase a place, we have to hire several engineers. That engineers can be network engineer, server engineer, storage engineer, virtualization engineer, OS engineer. All the engineers we need to hire. Then we need to purchase the data center, stack, router, switches, everything we have to set up. So that means everything we have to set up, from place, data center, everything we have to purchase. Okay, we have to create our own infrastructure, and everything will be managed by us only. Okay, then second option, you will see infrastructure as a service. So what we do, we get infrastructure as a service. For example, you want to use one virtual machine, what you will do, you will just create those virtual machine and you will use it. And what all things we have to manage, if you see the blue one, application, data, runtime, middleware, OS, all these things will be managed by us, and rest of the things will be managed by the any cloud providers. It can be IBM, it can be Azure, it can be AWS, anybody, any cloud providers. So what they will do, they will internally on their data centers, they will create all the infrastructure, all the servers. All we have to use those servers. Then again, we have platform as a service. That means all we have to deploy the applications. We will get everything ready. We need to only deploy our service and we can use. So we will get platform, all we have to deploy everything. Okay, and we can use those services. So if you see the blue one, applications and data, that we are managing. The rest of the things will be managed by the Microsoft. Okay, and the fourth one, you will see software as a service. So that means we are using their service as a software. So for example, if you see Google Gmail, correct, it's a one product, correct, but it's been used by us, so it's a SaaS product. Hotmail, again, it's a SaaS product. Azure DevOps, it's a SaaS product. Yahoo is a SaaS product. So we are using their service as a software. So even if we want to create, even we can say Flipkart again is a software as a service, because we are using their software to purchase something. Amazon is again one of the example of software as a service. Misho, there are many applications, they are software. Even we can call Facebook as a software as a service, because we are using their service. We'll talk more about Azure. So as I told you, it's a cloud computing platform that provides wide variety of services, and those services are compute services. In compute services, we can create virtual machine, we can create websites, we can create mobile services. Okay, there's this all services we can use in the Azure as a compute services. Again, in the data services, you will see, you will find storage account. If you, so data services mean, whenever you want to store something, some data, that time we will use data services. Okay, and the third one is application services. It's like you want to use, for example, AD service bus. It's all application services. Okay, and the network services, whenever you have to do something with a networking, that time we will use network services. That includes virtual network, content delivery network, Azure traffic. There are more available, load balancer, firewall. So APIM, these are all the network services. So on different purpose, we will use different services. For example, if you want to host one site, that time we will use compute services. If you want to store something, we will use data services. If you want to do networking from if you want to connect one region to another region, then we will use network services. So on the dependency, we will use those services, and those services can be integrated with each other. So let's see the revenue of AWS, Azure, and the GCP. So I have the data till 21, okay, 2021. So if you see the market of a cloud, Microsoft is so high. If you see the blue one, okay, and now you will see in 2021 quarter 3, it's almost high compared to AWS and the Google Cloud. So what we can see using this, what we can see in this diagram, so revenue of a Microsoft cloud is so high compared to AWS and the Google Cloud. Even if you see, most of the users are also, companies are also using Microsoft cloud. I have seen several companies switching from AWS to clouds. Okay, so now we'll talk about the Azure DevOps. As I told you, correct, Azure DevOps is a SaaS product. It's a Microsoft product. So what people think Azure and Azure DevOps the same? No, they are different thing. Azure DevOps is a SaaS product from the Microsoft. It's a software we use for orchestration purpose. We use this software. We use this software for orchestration purpose, for DevOps orchestration. So before we go on DevOps, Azure DevOps, so let's understand what is DevOps. So it's a combination. You can understand, it's a combination of two words, development and the operations. It's not tool. Normally, what people do DevOps is a tools. No, it's not tools. In DevOps, there are multiple tools. To achieve the DevOps, we have to take help of multiple tools. So basically, it's a culture to promote code deployment, fast code deployment. Using DevOps, what we can do, we can speed up the delivery of application. That all we can achieve using DevOps. And in DevOps, it enables organization to serve their customers strongly and better in the market. You can see the diagram. To achieve the DevOps, we have to align the team. So in the DevOps, to achieve the DevOps, we need development team, business team, operation team, quality assurance team to work together to achieve the DevOps. And you can see here. So these are the drivers. You can see the drivers of the DevOps: business agility, agile, development testing, infrastructure automation, proactive operation, continuous feedback, and visibility. These are the drivers of the DevOps. What problems led to the creation of a DevOps? So what happened, people starting using DevOps? I'll tell you. Few years back, development team and operation teams were working isolated way. Okay, there was no coordination between them, and whenever developer was deploying, developer was deploying code in the dev environment, it was working fine. But as soon as the code goes in the production environment, it wasn't working fine. To fix that problem, DevOps has been introduced. Okay, and with And with that, what was happening, people were spending lots of time in deploying, testing, and designing and building the projects. Okay, and there was so much human errors, and coding errors were, again, there was so much coding errors, nobody was reviewing, there was no way to review the code, everything was manual, even code deployment was the manual, and there was no coordination between the team. It's see, if there is no coordination between the team, it's okay for the small project, but if your project is big and without coordination, nothing, your project will not go live. Okay, so that's a problem, DevOps came in picture. And signs that show you need DevOps. So earlier, what was happening, development team was not able to defect software in the early stage of development. Okay, agile methodologies were used, but they were not agile methodologies were used, but agile is limited to development only. Okay, but for our deployment purpose, we need DevOps. Okay, and testing and development teams are not able to access resource timely, so the development team process delays. And in initial days, we were not able to identify exact problems of development, testing, and production. And there was and whenever there is a simple errors, human errors, so that, and once the production is once your app is in production, what developers used to think their job is over. It's not the case. Even though your project is your code is in live, job is not over. Okay, it's not the, and everybody was blaming each other. So that's, if all this is happening, that means we need DevOps to improve our process. So let's see the life cycles of a DevOps. It's a integration of as I told you, correct, it's an integration of a development operation process. One cannot implement DevOps without understanding its life cycle. So if you see the life cycle, it starts with a development, then it goes on the integration. Integration means merging code. For example, there are 10 developers are working, correct, merging their code in a one place is called integration. Then testing this code, then monitoring those codes, deploying those codes while after testing, then monitoring the application, then feedback, then again deploying to the production environment, then operations, then deployment. So it's a very short life cycle of the DevOps. And to achieve the DevOps, there are so many orchestration tools available. Okay, so if you see, Jenkins is again one of the orchestration tool. Azure DevOps is orchestration tool. Travis is orchestration tool. Circle CI is the orchestration tool. GitLab is orchestration tool. TeamCity is orchestration tool. CodeShip is orchestration tool. AWS DevOps is the orchestration tool. So these are the orchestration tool, DevOps orchestration tool. So we'll talk about the Azure DevOps. Okay, so Azure DevOps is, as I told you, correct, it's a DevOps orchestration tool. It's a Microsoft product. It provides ALM solution. ALM is application lifecycle management solution that includes source code management, require management, project management, automated build, automated testing, automated release. All these capabilities will be provided by the Azure DevOps. In short, it's a combination of all tools together. If you see, these are the features available in the Azure DevOps: Azure boards, Azure repos, Azure pipelines, Azure test plans, and Azure artifacts. So if you see this picture in Azure DevOps, you will get all these features. Collaboration in Azure DevOps, you will get benefit of repos, pipelines, boards, test plans, artifacts, and collaborations. So let's understand about their feature. The first feature is Azure Repository. It's a version controlling tool. Okay, so in the market, if you see, you might know about GitLab, GitHub, Bitbucket. It's all Azure repos mimic the functionality of a we can say GitHub, we can say Bitbucket. Whatever features we will get in Bitbucket, GitHub, we can use it in Azure repos. It's a version control tool. For example, if you are writing some code over there, correct, and you put your code in Azure repos, even after 10 months, 10 years, you can get that code. You can create multiple branches. So multiple branches means if there are 10 developers, correct? So what developers can do, they can create their own branches and they can keep track of their work. That's all achieved we can using Azure repos. Then Azure pipeline, it's a feature provided by the Microsoft. Using that feature, what we can do, we can enable continuous integration and continuous delivery. And what people think, that Azure pipelines can be only integrated with Azure. It's not the case. We can deploy application anywhere. It can be on Google Cloud, AWS, anywhere public application can be deployed. And in the Azure pipelines, you will get all the extensions ready. Then third feature is Azure boards. Azure boards mimic the functionality of a Jira. You might know about the Jira, correct? It's the same. Whatever we can do in the Jira, we can do it here. So why boards are using? Why we use boards? For example, you are taking the requirement from the user stakeholders. So what you can do, you can take the requirements and you can store the requirements here, and you can assign this requirement to all of your employees. And here we get benefit of a Scrum and Kanban dashboard. And using boards, we can track our work. Okay. So test plans. In test plans, what we can do automated testing. Somebody wants to do Selenium testing, correct? That can be done. Somebody wants to do user testing, manual testing, that can be done. If somebody wants to do functional testing, performance testing, all these testings can be performed using test plans. The artifacts, for example, you created one artifact and you want to store that artifact. So what we can do, we can store that artifacts over in the artifacts, and we can get benefit of public artifacts also. If somebody wants to use NuGet packages and PM Maven packages, all this can be used from the artifacts. And collaboration tools. So in collaboration tools, what we can do, we can create our own wiki page. Like we have one project and we want to put all the information about that project. So what we can do, we can put all the informations of that project in the wiki pages. We can create our own pages and we can put all the informations. If somebody wants to know anything, what they can do, they will just go to a wiki page and they can check whatever informations they need. So as I told you, correct, there are many orchestration tools available, correct? Jenkins is again one of the orchestration tools. So I'll talk difference about the Jenkins and the Azure DevOps. See, Jenkins is something you have to install on your machine. And Azure DevOps, it's again, I told you, correct, it's a Microsoft product. All we have to create URL and we can use it. It's like we log into the Facebook, correct? Similar way we have to do it over here. Jenkins is open source. It's a free Azure DevOps is free only, but it's free for limited users only. And Jenkins used for build and deploy. Azure DevOps is also used for build and deploy, but in Azure DevOps we can integrate Jenkins also. In Jenkins there are tons of integration. Yes, here also there are tons of integration, and with that we can do project management also here. In Jenkins, there are rich set of plugins. Again, here we have in Azure DevOps. Again, there are so many extensions available. But in Azure DevOps, you don't need to install those extensions. There are already extensions are available. So we can configure configure our pipeline as a configuration code. Similar thing we can achieve using YAML based code. In Jenkins, it's a minimal design. In Azure DevOps, it's an integrated artifacts management. It's a share. In Jenkins, the libraries are shared, and in Azure pipelines, there are fully developed templates are available. So one thing I want to add in Jenkins, if you use Jenkins, correct, it is just for CI/CD. So for example, if you want to use Jira, you want to use board feature, you want to store some data like user stakeholders, what stakeholder is asking you to create. You can do it in Jenkins, but for that you have to integrate other tool. Jira, you have to integrate Jira with Jenkins. But in the Azure DevOps, you don't need to integrate Jira. There is Azure DevOps already have one tool which is called Azure Boards, which we can use to take users in stakeholders information. Again, one more in Jenkins, if you want to do version controlling, we have to do, we have to integrate Jenkins with a Git. Okay, whereas in Azure DevOps, Git is already integrated, Bitbucket is already integrated, so we don't need to integrate that. Again, for the artifacts purpose, we have to integrate other two like Nexus, JFrog Artifactory. We have to integrate the Jenkins. Whereas in Azure DevOps, we have our own artifacts, so we don't need to go outside. If we use Jenkins, so Azure DevOps, but we use Jenkins, we have to go outside for multiple things. Okay, so that's a difference between Jenkins and Azure DevOps. And you can see the job opportunities for the Microsoft Azure DevOps. So there are several jobs available for the Azure DevOps engineer. You can see here, correct? Accenture. So there are several jobs, LTI. There are several jobs available in the for Azure DevOps and DevOps engineer. And to learn Azure and Azure DevOps, and to be Azure and Azure DevOps engineer, what is the prerequisites? You should know at basic of a C Sharp, Java, Angular, any languages. If you know, that's fine. And you should know what is the basic functionality of a server. What is server, and how do we use server, and what's the purpose of server? If you know this thing, then we are good to go ahead. Thank you so much. Any